Now, we have seen what is merging, and also we have seen how multiple lists can be merged together, that is in two-way merging or m-way merging we have seen. And if there are multiple lists, then we can merge them in different patterns. We have seen that. Now let us see merge sort, that is a recursive procedure. And this is divide and conquer procedure. The divide and conquer strategy says that if a problem is large, then break the problem into sub-problems, and if the problem becomes small, then solve it and combine the solutions of the small problems or sub-problems to get the solution for main problem. So here the problem is to sort these elements, and we say that the list is very large. Then what is small? So basically if there is a single element, then we say it's small. So single element means we don't have to sort it. So yes, in merge sort we say if there is just a single element, then we don't have to sort it. Otherwise, if there are two elements also, we have to call it as a bigger problem or large problem. If there is a single element, then we say it's a small problem. Merge sort follows divide and conquer, therefore it's a recursive algorithm. Let me write the algorithm, then I will trace the algorithm. Let us see. Algorithm merge sort. What are the parameters it takes? It takes two parameters, that is beginning of a list and ending of a list. So low and high. Then we check if low is less than high, means if low is equal to high, it means there is a single element. Low is less than high means at least there are two elements. So list is large. If low is less than high, then we will find out mid, that is low plus high by 2. What for we are finding mid? Like if I find 1 plus 8 by 2, that is 9 by 2, I get 4. So this will be mid. What for? We say that this problem is large, so we break it into two sub-problems. That's what we find mid. Then what to do with the left hand side? Perform merge sort recursively. Perform merge sort on the right hand side recursively. So perform mid, find out mid, and perform merge sort from low to mid. And also perform merge sort from mid plus 1 to high. So by performing merge sort on the left hand side, we will sort this one and we sort the right hand side. So when two lists are sorted, we are breaking this into two lists, and when two are sorted, we can merge them together. So perform merge. Merge from where? Low to mid is one list and mid plus 1 to high. So we pass three parameters. So that's all. This is a simple algorithm for merge sort. This is divide and conquer. How merging is done? We have already seen the procedure how merging is done. But the point here is, when the single array is given for sorting, we are breaking into two sub arrays and we are saying this is one first list and that is second list. So single array will be containing two lists and we have to merge them. So can a single array have more than one list? Yes, a single array can have many number of lists. Let us see how it works. Let us see the tracing. Now based on this algorithm only, I will do tracing. Initially we will be passing low as 1 and high as 8. So let us take for these set of elements. So first time we will pass 1 and 8. It will find out mid and it will divide the list, and this side and that side. So mid is perform and perform merge sort from low to mid, that is from 1 to 4. It will go this side. And it has to go on the right hand side also, but not now, it will go afterwards. But I will draw this one also. So let us take this one. So it will call itself from 5 to 8 on the right hand side. So it has broken them into two lists, first part and the second part, and then afterwards merge. So first of all, let us finish this and this. Now MergeSort calls itself. Low is less than high. Yes, 1 is less than 4. So again find out mid and call these two. So it means these 4 elements are also large. Divide them. So this side 1 to 2 and this side 3 to 4. Now when we take this, again low is less than high. Yes, there are 2 elements, so this is still large. Again split it. So 1 to 1 on this side and 2 to 2 on this side. Now there are just 1 elements. See, if you have seen previous video, you may know how two-way merge works, two-way merge sort works. See, if you have seen previous video, you know how two-way merge sort works. Now here also merge sort is working in a similar way. One array was given, so it has splitted and then splitted, then splitted. Now it has reached one element. Now one element is there means it's a single list with one element. Now these two can be merged together. 3 and 9 are merged together. So the first merging is done for these two elements and their result is obtained here. So this is the first merge done. This is the first merge done. It will merge these two elements. So 3 and 9 are merged. Then coming to this side, it will split them and get 3 on this side and 4 on this side. Then it will merge the elements. 3 and 4 are merged. So first 9 and 3 were merged. So the result was 3, 9, and now 5 and 7 and 5 are merged. Result is 5 and 7. This is combined. Now it will go back and perform merge here. So this is the third merge. So it will merge these two. So the result is 3, 5, 7, 9. Now this side is sorted. Actually we have to sort this whole array. Break it and break it and break it. Now 2 elements merge, 2 elements merge. Now merge these two also. So this side is sorted. Now same thing is done on the right hand side also. 5 to 8 is there. So on that side it will divide this from 5 to 6. And that side it will be 7 to 8. And 5 to 6 will become 5, 5 and 6, 6. Now 1 element each. This is again splitted, 1 element. So these two are merged. So it becomes 4, 6. So this is the fourth merging. Then it will go this side. It will split again, 7, 7 this side and 8, 8 this side. So it will split this also. Then again these two are merged. So it becomes 2, 8, one more list. So this is fifth merging. Now as these two are already sorted, it will merge these two. So it becomes 2, 4, 6, 8. So this is sixth merging. And then these two lists are merged to get a single list, that is 2, 3, 4, 5, 6, 7, 8, 9. This is single sorted list, that is seventh merge here. So this is how MergeSort works. When a single array is given, recursively it will divide that array into smaller pieces until it reaches one element, then it will start merging them. So you can see that 8 elements were given, splitted, then splitted, then splitted. Now they are merged, merge, merge. So this is the working of MergeSort. Alright, so it's similar to two-way, but in two-way MergeSort, we just take first 2 elements, the next 2, the next 2. But this is divide and conquer, and this is recursive. So it will simply divide, and then that's how it reaches one element. Then it will start merging them. So what is different is only the pattern is changing. The approach, rest of the things are same. Right? Result is sorted, and it is also merging 2 lists at a time. So it is also two-way. But as it is recursive, we need some another name, so we call it as MergeSort. Let us see the time taken by MergeSort. So from the tree, the recursion tree, that is the tracing of that algorithm I have done. So I'll show you how the time is, I will show you how much time it takes. See, the merging has started in this level. This was just splitting. So how many elements are merged here? Two elements merged, two elements. Total how many elements? 8 elements are there. 2, 4, 6, 8. 8 elements are merged here. So I will say n elements are merged, all n elements. Then again merging is done at this level. So 8 elements are merged. Then again 8 elements are merged here. So n elements are merged each time. So total how many levels are there? 1, 2, 3 or 1, 2, 3. So total 3 levels are there. So for 8 elements I got 3 levels. It means it is log of 8. Log of 8. 1 and then 2, then 4. So when something is raising by 2 every time and it is power of 2 lastly, power of 2, that is 3 at the last, we are having 8 elements total. So 3 is log of 8. So how many passes are there? So actually these are not passes because it is recursive. First it will enter this side, then it will go that side. So it is not passes, right? First it will finish left side, then right side. But levels if you see. So total how many levels? Log n levels are there. So this will be n, how many times? Log n times. So the time taken by MergeSort is theta of n log n. That's it. So the time for this one is also n log n. Now taking these numbers, I'll show you how this MergeSort works. Low and high are taken. So example is 1 and 8. 1 and 8. So let us see, using the numbers I'll show you. First of all, it will find out mid and it will call MergeSort on the left hand side. So it will take these numbers and call 9, 3, 7, 5. MergeSort is called on this. Then now this is 1 to 4. 1 to 4. Again, this becomes 1 to 4. So this is the first call, right? First call. Then 1 to 4, the first recursive call. 1 to 4 is 1 is less than 4. So again it will call itself by finding mid, it will call itself. So again it will split. So this is 9 and 3. So just 1 and 2. 1 and 2. Then again this is also low is less than high. This is low and this is high. Just you can follow that one. Find out mid and split it. So 9 on this side. This is just 1 comma 1. And 3 on this side, just it is 2 comma 2, right? So it has called itself and itself and itself again. So this is one list, it has splitted, then again this is splitted, again this is splitted, and this side. Now these two are merged, so the result become what? 3, 9, right? Then it will go on the right hand side, so this becomes 7, 5, that is 3, 4. Then it will come on the left hand side, this is just 7, 3, then it is just 5. So these two are merged, so it becomes 5 and 7. Second call has finished. Now this side is completed, this side is completed. So what is the next step? Merge. So these two are merged, so this becomes what? First 3, then 5, then 7, then 9. So that's how it has splitted, then splitted, then splitted, then merged. So till here it got the result. Now it will go on to the right hand side. So this part, second part for this one. So this will be 6, 4, 8, 2, and this is from 5 to 8. This one. Now on this, 5 to 8. On this one it is called 5 is less than 8. Yes. Again find out mid and call MergeSort, this one. So on the left hand side it will be called. So this will become 6, 4, it will be 5, 6. Indices are 5, 6. Then on this again MergeSort is called. So 5 is less than 6. So again find mid and call MergeSort. So it will become 6, and this is index 5. Now low is also 6, high is also 6. It will go on the right hand side, this call for this one. So this will be 4 and the index is 6. So low is also 6, high is also 6. Then merge, these two are merged. So it becomes 4 first, sorry. Then it becomes 4 first, then 6. Then it will go on the right hand side of this one. So right hand side is 8 and 2. This is index 7 and 8. Now low is 7, high is 8. So low is less. Again find out mid and call this one. So this side it will be 8 and it will be 7. Now just one element. So go to the right side. 2, single element. Now merge. So left side completed, right side completed. Now merge. So 2, 8. It becomes 2, 8. Now this side, both are sorted, merge. Both are sorted, then merge. So this becomes 2, 4, 6, 8. So this becomes 2, 4, 6, 8. Now this is also sorted. This was already sorted beforehand, left hand side it went. Now these two are merged together. 2, 3, 4, 5, 6, 7, 8, 9. So in this way, this list becomes 2, 3, 4, 5, 6, 7, 8, 9. Sorted. This is how MergeSort works. Tracing I have done. See, earlier I have shown just indices. Now in this I am showing numbers. And as it is calling itself 2 times, the tracing tree will be more like a binary tree. It will be like a binary tree. And if I say the traversal, then in which traversal merging is done? Post order. First left, 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 then right, then root, merge. Right? Then right, left, then right, then root, merge, root, merge. So merging is done in post order traversal. That's it. So I have shown you tracing in 2 different ways. Now let us find out the time complexity of this algorithm by using recursive. For this recursive algorithm, let us prepare recursive and find out the time complexity of MergeSort. If I say this algorithm takes Tn time, then this is one condition, and this, if I ignore condition and I say this is calculating mid, then it is calling itself, so T of what? Half of the list, low to mid, half of the list, so n by 2, and again calling itself, so this is also n by 2. Then it is merging from where? Low to high. 2 lists are there, low to mid, mid plus 1 to high, 2 lists, total n elements. So merging takes n. So if I prepare recursive by adding all these, ignore one there. Now this is Tn is equals to 2 times Tn by 2 plus n. So the recursive is Tn is equals to 2Tn by 2 plus n when n is greater than 1. What it is doing when n is equals to 1, it's not doing anything. So we don't write 0, we can write 1 or some constant. Okay, some constant means 1, 10, anything you write. It's not doing anything, so better write 1. This is the recursive. Now by using Master's theorem, a value is how much? 2, b value is how much? 2, and f of n is what? N. Now find out log a base b. So that is log 2 base 2 is 1. And power of n, k, it is 1. So this is log 2 base 2 is equal to k. They are equal. So we compare these two, and this is falling in case 2. Case 2. So case 2 says what? Whatever f of n is multiplied by log n. Write f of n as it is and multiply it by log n. So I am using master theorem. Already this recurrence relation is solved in another video. You can look for that video. Right? It is in the second topic, that is divide and conquer. I have solved few recurrence relation. This you will find in the title of a video itself. Now here I directly am using master's theorem. There are videos on master theorems also. So time is theta of n log n.